Now another question. Obtain the transfer function. Obtain the transfer function of the mechanical system shown below. So here they are saying this is a mechanical system, so we don't know whether it is rotational or translational. So rotational means like you are keeping me on my table and you are asking you are keeping me on my table and you are making the table rotate. When it is a rounding, I am on the table. Translational means I am standing at one place, you are giving force, so I am moving my place. So that is the difference between rotational and translational. So translational means, what did I say? I was at one position, you applied a force on me, so I was just moved from one place to the other place. Rotational means you kept me on a table and you are rotating the table, so I am going around, so I am in a rotational mode. So now this system is called as rotational system. So the question is given as obtain the transfer function for the mechanical system. So mechanical systems are two types. One is translational and the other is rotational. Rotational means you are keeping me on my table and I am rotating. Translational means you are making me stand at one position and you are forcing me to move. I am moving. Means I am changing my place. So these are the two types. So by seeing the picture, you should know which type of system you are. Okay. So according to this given question, so this is the question. So according to this given question, what is the question given? T applied torque with theta 1. It means torque is the input which makes the mass of the body move. So when you're applying torque means you are in a rotational mode, right? So it means mass of the body is called as moment of inertia, damper will be damper, spring will be spring. So T is equals to J plus D plus K. Okay. So usually what we were writing, we are saying that when a force is applied, my body is moving. Because of my body, my dress is moving and my ornaments are moving. Same concept. I am on a table, you made me rotate. Now I am in rotational. So now my input is torque. My body is called as moment of inertia because I am experiencing some difference in my movement. But my dress will be dress, my ornaments will be ornament. Clear? So moment of inertia, damper and spring. So this will be the same. Only mass will be changed as moment of inertia. Instead of force, you should give torque. Okay? So displacement is x, means I change it from one place to another place. So my place is displaced. So this is called displacement x. But in rotational, I am at one position, but when I was rotated, I made an angular movement. So this is called as angular displacement or angular movement, whatever it is. Okay, displacement, angular displacement. When force is given, you will displace, means you will just move a certain point. When torque is given, you made an angle rotation. Maybe you are at 0, you went to 30 degrees, like that, angular. So then what happens? Now the equation is, we should consider our picture. So according to our picture, usually we are writing the equations as F is equals to m d square x by dt square plus d dx by dt plus kx. But now what you will write? Instead of t, instead of f you will write t, instead of m you will write j1, instead of x you will write theta. That's it. The other terminology is same. So now the equation you are going to consider should be this. Reason is, input is applied torque. Clear? And angle is given as theta, right? So this is called as angular displacement. So now if your question is given like this, your answer is supposed to be, okay, so first what are we saying? What is the moment of, what is your mass of the body? Okay, so the mass of the body is what first they said is J1. So to J1, what is there? T, applied torque. It means to J1 torque is there. Okay, so first you should draw the picture, right? So let us first frame our picture. So to J1 torque is applied, it means T of T is there. Then theta 1 is there, it means its displacement is theta 1. Then theta 1 applied, T is applied to J1, K is connected, but K is in connection with J2 also. So I will write J2 having a connection with K. So K is in between. Then K is done, J2 is done, is having an angle theta. So here angular displacement is theta. Sure. Then after theta, you can see theta is the output. They are saying theta is the output. Okay, fine. Then can you see this? This shape is like, this is the symbol for, this is the symbol for damper, means dress of a system, right? So it means there is a damper, and the damper is represented as F. You remember at the beginning I said damper will be represented as D, and sometimes it will be represented as F as well, right? So that's what I said. Damper can be represented as D or F also. So in this problem it is represented as F. So it means to J2 F is connected. So if it is, so in this system F is connected. So if torque is there, torque will be torque. Theta 1, K is there means K is written as theta 1 minus theta, because both are in connection. And F is written as, F means damper, F d theta by dt. So now what will be the equations? The first equation for J1 will be, usually T is equals to, that's what our equation, right? T is equals to J plus D plus K. So T, yes, to J1 T is there. So T of T is equals to J1 D square theta 1 by dt square. The reason is here theta 1 is there, plus any damper here, no damper, so there is no D or F. Then any K here, yes, K is there, and K is in connection with both. So theta 1 minus theta. This is the first equation. And coming to the second equation, this is second. So take second equation, is there any T? K is there, F is there, that's it. So 0 is equals to J2 D square, and here angular displacement is theta, D square theta by dt square, plus F is there, so F d theta by dt, plus K, yes, K is there, but K is in connection with both. When we are talking about J2, we should give importance to theta. So theta minus theta 1. So this is equation 1 and this is equation 2. Okay, so now this is just an introductory part. Now we should go to solution. Okay, so now if a question is given like that, first what you should do, you should draw this picture, that's it. Okay, so first you should draw the picture. So what is the picture? Picture is J1. Okay, so J1 is there, then to J1 you have connections with to J1 you have connections with T of t, then K is the connection between J1 and J2, and here damper f d theta by dt is there, so K is in between, so we are saying theta 1 minus theta, right? So this is our picture. So according to this I should write the equations. So to write the equations, what I am supposed to do, I should be writing first my differential equation for J1. So what is J1 differential equation? Okay, the differential equation is, what is the differential equation for J1? It is T of t is equals to J1 d square theta 1 by dt square plus, there is no damper here, we have only t and k, so t is there, k theta 1 minus theta, because we are talking about J1, so we should give importance to theta 1. Okay, now let us separate these two. So T of t is equals to J1 d square theta 1 by dt square plus k theta 1 minus k theta. Then what we should do, apply Laplace transform on both sides. So then it will be T of s is equals to J1 will be J1 because it's the coefficient, d square will be s square, small theta 1 will be capital theta 1 of s, plus k is the coefficient, k will be k, theta 1 will be theta 1 of s, minus k is the coefficient, k will be k, and theta will be theta of s. Clear? So now what it is going to be, so now we wrote for T of s, right? Just see the question first. The question is, obtain the transfer function of the system. But actually what do you mean by transfer function? Transfer function is output by input, right? Here if you see applied torque, it means they are saying it is input, so input means it should be T, so input means it should be T, and then they said theta is the output, so theta is the output means what it should be, theta. So the question is about theta by t. Before you start itself you should realize what is your aim. So your aim is to find theta by t. That means when you started deriving the solution, you should know that your requirement is t by theta but not theta 1, right? So you should eliminate theta 1. So for that what I am going to do, so T of s is equals to theta 1 of s, I am taking it as common, so J1 s square plus k minus k theta of s. So I want something for theta 1, so I will send this side. So T of s plus k theta of s is equals to theta 1 of s into J1 s square plus k. My requirement is theta 1 of s. So theta 1 of s is equals to numerator. I will write it in numerator. Here it is a multiplier, so when it goes this side it will be denominator. So J1 s square plus. So now I got something for theta 1. It means I have a chance to eliminate theta 1. Clear? Now next my equation is for J2, right? So for J2, if you see J2 is having only kf but there is no t, So only k and f. So 0 is equals to j2 d square. Here angular displacement is theta by dt square plus f d theta by dt, because it is having f, plus k is between both. So when I am talking about j2, I should give importance to theta. So I am writing it as theta minus theta. So let me separate this. So 0 is equals to j2 d square theta by dt square plus f d theta by dt plus k theta minus k theta 1. So apply Laplace transform. So if you apply Laplace transform, what happens? So now 0 will be 0 only, j2 will be j2. So let me write the Laplace transform. So the Laplace transform will be 0 only, right? So 0 is equals to j2 will be j2, d square will be s square, small theta s will be capital theta of s, plus f. This is a coefficient, so f will be f d theta. So d theta means s theta of s, plus k theta. So k theta of s minus k theta 1 of s, right? So 0 is equals to, let me take theta of s as common. So this will be j2 s square plus fs plus k minus k theta 1 of s. My requirement is theta and t, but not t1. So to eliminate this t1, I am already done doing a solution like this, right? So I can substitute this equation here. So now it will be 0 is equals to theta of s, right? 0 is equals to theta of s into j2 s square plus fs plus k minus k into, what is my theta 1? My theta 1 is t of s plus k theta of s. So t of s plus k theta of s by j1 s square plus k, j1 s square plus k, right? So this is equals to, 0 is equals to theta of s into j2 s square plus fs plus k minus, let me multiply k with these two. So this will be k t of s plus k square theta of s by j1 s square plus k, right? So what should I do? I should make this theta of s common, right? So if I take theta of s as common, let me first write these two. Okay, so what I will do is theta of s into j2 s square plus fs plus k minus k t of s by j1 s square plus k minus, because minus into plus is minus, minus k square theta of s by j1 s square plus k. So this term is theta of s, this term is theta of s. Here there is no theta of s, so let me send this that side. Okay, so now what happens? I can write this term this side, so it will be k t of s by j1 s square plus k is equals to, so this is gone, that's it. So now here I am taking theta of s common for these two. So if I take theta of s common, it will be j2 s square plus fs plus k minus k square by J1 S square plus K. So A minus B by C. So I can take an LCM. So this is equals to LCM J1 S square plus K. So theta of S will be theta Fs only. So into J1 S square plus K into J2 S square plus Fs plus K minus K square. What is this side equation? So this side the equation we are having is K T of S by J1 S square plus K. So if you see denominator same. Let me cancel these two. Can I do it? Denominator. A cancel. Same. So now what is the numerator equation left over? K T of S is equals to theta of S into, in numerator or denominator any multiplication shouldn't be there. So let me just multiply. J1 S square into J2 S square. It will be J1 J2 S power 4 plus J1 S square into Fs. J1 F S cube plus J1 S square into K. J1 S square K plus K into J2 S square. J2 S square K plus K into Fs. Fs K plus K into K. K square minus K square. So A square minus A square, K square minus K square, everything can be deleted. So now here K T of S is equals to theta of S into, first I should find what is S power 4. S power 4 I have only one term. So S power 4 into J1 J2 plus S cube into S cube, I have only one. So J1 F plus S square into S square, I have J1K J2K. So J1K plus J2K plus FSK. So this is the leftover equation. Okay, my requirement is what? At the beginning itself we decided that our equation should be theta by T. Theta is here, so T should come this side. When T should come this side, okay, when T should come this side, this should go that side. So what it will be? Theta of S by T of S is equals to, so theta of S by T of S is equals to K by, right? K by S power 4 into J1 J2 plus S cube into J1 F plus S square into J1K plus J2K plus FSK. So finally this is our solution. If you can't do this multiplication, of course if you do like this, 20 out of 20, but if it is like you don't want to take all this stress to multiply these and confuse somewhere else, you can even stop it here, because when you eliminated these two, here you can see K T of S is equals to theta of S into some multiplication. Never mind, just say theta by K is equals to K by this, simple. So you are not going to do these steps, then you will be lost with 2 or 3 marks. Rather than doing a mistake, it's better you stop here so that you save that, right? So you can solve like this. So this is the solution. So the question will be given as obtain the transfer function for mechanical system. They said mechanical. They didn't mention whether it is translational or rotational. Okay. So you will be checking. So mechanical systems are of two types. One is translational. Translational means if you apply force, body will move, mass of the body plus a dress, a damper will move, plus a spring means the ornaments will move. If you talk about a rotational, you will give torque, body will move, dress will move, and ornaments will move. Here displacement is x, means you moved from one place to another place. Here angle is angular displacement, theta, means you moved with an angle. So these are the considerations you should remember. So when they said mechanical system, first you should see, okay, torque is given, means obviously it's a rotational system, so your equation should be in this form. So these you should get into mind. Okay, so if the question is given like this, your solution should start like this, and this is just your mind should remember, okay, this is how I should solve. So this is for remembrance, but solution is, question will be this, solution will start like this. First frame your single line diagram, then say for J1 this is the equation, then J2 this is the equation. But in J1 itself you will decide that what is theta 1. Reason is, question is output by input. Here already they said output is theta, it means you need is theta by t, so it means you don't want theta 1. So you eliminated theta 1 from the first equation and you wrote the equation for second and you substituted it and you framed until here. Here if you can, just finish the solution. If you can't, stop it here. Theta by t is equals to this by this, done, never mind. Okay, so finally you got k by s for 4, s cube, s square, yes, right? So this is called transfer function of the given system. Sure.